Let's talk about something most of us use every single day but probably never think twice about: elevators. We're going to dive into a really critical but kinda hidden safety issue known as wire rope slip. And to help us understand it, we're drawing on some expert analysis from the folks over at Novin Pooya Elevator. I mean, think about it. If you work in an office building, you could be spending something like 15 minutes every day just riding in an elevator. We step inside, push a button, and trust. We completely take for granted this incredible piece of engineering that gets us where we need to be. But have you ever stopped to wonder what's actually going on above that ceiling panel? The incredible forces at play? There's this whole intricate dance of steel and friction happening, and deep within that system, there's a potential threat that engineers work around the clock to prevent. Okay, let's get right into it. The most common type of elevator, the kind you're probably picturing, is a traction elevator. And its entire operation, literally everything, depends on the grip between the steel wire ropes and that big grooved wheel that pulls them. When that grip fails, even a little bit, that's when you run into trouble. So what is wire rope slip? Well, in the simplest terms, it's when the ropes start sliding against the main pulley, or sheave, instead of moving perfectly together with it. It might not sound like a huge deal, but this tiny, unwanted movement is the first domino to fall in a chain reaction that can lead to some really serious problems. Now here's where things get really fascinating. Not all movement between the rope and that sheave is bad. In fact, engineers have to deal with two totally different things. One is called creep, and the other is slip. Knowing the difference between them is absolutely critical. To really get what's at stake here, you have to separate these two ideas. So on one hand, you have creep. Creep is actually totally normal. It's just the rope naturally stretching and contracting a tiny bit as the weight shifts from the car side to the counterweight side. It's physics. It's predictable, and it's actually a sign that the system is working exactly as it should. Slip, though, that's the dangerous one. It's an uncontrolled slide because of a loss of friction, and it's a huge red flag that something is wrong. So yeah, creep is totally fine. It's the slip we have to worry about. And it's not just a one-time thing. A slip event is like pulling the trigger on a devastating chain reaction that can put the whole elevator system at risk. And it all kicks off with that one moment, that initial loss of grip. You know, maybe it only lasts for a split second, but that's all it takes to start this destructive cascade. The first victim in all of this is the wire rope itself. When it slips, that friction creates intense heat, basically grinding away at the steel. This leads to really bad uneven wear. The rope starts to fray, its structure gets weaker, and in a true worst-case scenario, you're looking at the terrifying risk of it breaking completely. But the damage doesn't stop with the rope. Now you have this frayed, damaged rope acting like a piece of sandpaper on the very wheel that's supposed to be gripping it, the sheave. It literally carves away at those carefully engineered grooves, changing their shape, and, you guessed it, making it even harder for them to get a good grip. And this is where it turns into a really nasty, vicious cycle. The damaged sheave can't grip as well, which causes more slipping. Of course, more slipping causes more damage to both the rope and the sheave, which reduces the grip even more. It's a feedback loop from hell that just gets worse and worse. So what does this mean for you, the passenger? Well, at first, it might just be some weird noises or a bumpy ride. Then you might notice the elevator isn't lining up perfectly with the floor anymore, creating a tripping hazard. And in the most serious cases, it can cause sudden, jarring stops or even a complete loss of control over the car's movement. That's the nightmare scenario everyone is trying to prevent. Okay, so that all sounds pretty scary. How do we make sure this never, ever happens? Well, the answer is a combination of really smart design right from the start and incredibly diligent, proactive maintenance. This is where the real expertise comes in. Prevention actually starts with the design of the sheave itself, specifically the shape of its grooves. Engineers have to make a choice. A U-groove, for instance, is gentler on the ropes, which is great for modern, high-speed elevators that have super precise motor controls. On the flip side, a V-groove gives you a ton more traction, but it also wears the rope out faster, so you might see that in older systems that need that extra bite. It's a critical engineering trade-off. But even the world's best design doesn't mean anything without great maintenance. Expert technicians are constantly running crucial checks. They're using laser tools to get the alignment just perfect. They're using special gauges to measure wear in the grooves. They're always monitoring the rope's condition. They even make sure the counterweight is balanced perfectly. And these days, modern systems have advanced computer drives and sensors that can actually detect slip as it's happening and either correct it or safely shut the system down before it becomes a real danger. When you step back and look at it all, you realize that elevator safety isn't just about one single part. It's about building this entire comprehensive system of trust, where the design, the materials, and the maintenance all work together in perfect sync. And this is the foundation of that trust. It all starts with making the right design choices from day one, using high-quality, certified materials that can handle the incredible stress, and committing to a rock-solid maintenance schedule. And as experts like the team at Novin Pooya always stress, it means following international safety codes like EN 81 and ASME A17.1 to the letter. These are the rulebooks that keep everyone safe. It's this whole approach that engineers our trust in the system. So the next time you step into an elevator and press that button, maybe just take a second to appreciate the incredible unseen engineering that makes your ride so smooth and so safe. It kind of makes you wonder, doesn't it? What other complex, hidden systems do you put your trust in every single day without even giving it a second thought?